I put in your interim grade. I'm still working on a couple of tests, grading wise, so those should be in the next day. I got a little busy during planning, but that's going in. We have 26 days left of school. So that's going on there. Upcoming date. We just had our interim. Your mastery check over this stuff is tomorrow. Your extra credit is due Friday. Your next mastery check after that is the 23rd, then the 25th. Your next test is the 26th. Okay. Between the 26th and May 2nd, we have to cover a little bit of unit 7. So it's very, very, very quickly. Okay. Yeah, that's all I got to say about that. All right. So let's go ahead and get started. What does a circled data point mean in context of this graph? What does it mean in context of this graph? You okay? Okay. Is that a common thing? Okay. Okay. So what does the circled data point mean in context of this problem? So if ever you're given a graph, look at like your x-axis and then look at your y-axis. So what does the x represent? Okay, so that's 35 ounces of water. Drink. Okay. And what does this say? 6 restroom visits. Do y'all know how much water you drink in a day? No. Okay. You should have how many glasses of water? Is it 8 glasses of water? All right. How many ounces are in a glass? Okay, so let's look it up. How many ounces are in a glass? Okay, so a standard glass contains 8 ounces. Okay, and then how much water should you have in a day? And everybody always says like a gallon, which is not true. The National Academy of Medicine suggests that you drink 13 cups. It says 13 cups and 9 cups for healthy men and women. So 13 cups if you're a male, 9 cups if you're a female. Interesting. Someone else said most people need to drink 4 to 6 cups of plain water every day. So let's say that if you're drinking 4 cups of water, okay, then 4 times 8 would be how many ounces? 4 times 8, 32. Okay, so about 32 ounces. How many restroom visits should you have in a day? Like between 5 and 6. Do you go to the bathroom 5 to 6 times a day? I don't. No. But are we drinking enough water? That's the question. Okay. So which of the following correlation coefficients would be a good match for this scatter plot? Okay, is it positive or is it negative? Is it positive or negative? Positive. Okay, so we can go ahead and get rid of these negative correlation coefficients. Is it close together or is it kind of spread out? Okay, but is it like more towards the line? Yes. Okay, so it's not going to be that 0.2. 0.2 would be really spread out. Is it on the line exactly? Do they create a linear line? No. So probably the best bet would be 0.8 because they're close to the line, but not quite exact. Does that make sense? Okay, on your mastery check tomorrow, you're going to be asked to graph some correlation, like draw a graph of a correlation coefficient of 0.8. So you would draw something like this. Yeah. Okay. All right. So we're going to talk about interpreting what the correlation coefficient in context is. So here's some reminders. R is called a correlation coefficient. Correlation coefficient is one way to measure the strength of a linear relationship. The sign of R is the same as the sign of slope of the best fit line. So your correlation coefficient is your slope. Everybody understand that? Okay. The values for R go from -1 to 1, inclusive. So that means any number between -1 to 1. The closer to R is to 1 or -1, the stronger the linear relationship between the variables. The closer to R is to 0, the weaker the linear relationship between the variables. We talked about that yesterday. Okay. So what does the sign of the correlation coefficient tell you about the data? So if it's positive, that means that as X increases, Y is increasing. Okay? It increases. If it's negative, that means that as X increases, Y is decreasing. What does it mean to have a correlation coefficient of 1 or -1? That means that they are directly influenced of each other. Okay, for instance, an example of this would be shoe size. Okay, shoe size and foot length. As your foot length goes up, your shoe size goes up. Those are directly influential of each other. Yeah. Interesting. I asked for a correlation example. An example of ice cream and crime rates are positively correlated because both variables increase when temperatures are warmer. Didn't know. So apparently when it gets warmer outside, crime rates go up. I thought it was the other way around. Okay. So doctors suspect a strain of bacteria found in the hospital has become resistant to antibiotics. They put various concentrations of antibiotics in petri dishes and add some of the bacteria to allow it to grow. The bacteria grow in groups in the dish called colonies. After some time, the doctors return to the petri dish and count the number of colonies for the different amounts of antibiotic. Here's the correlation coefficient, which is -0.83. What does this sign tell you about the relationship between the number of bacteria in the colonies and the concentration of the antibiotic in the dish? So what does that tell you? Correlation coefficient is -0.83. Okay, you good? Yeah. So what does this tell you? So as I'm adding antibiotics, what is happening to the colony of bacteria? Is it increasing or decreasing? It's decreasing. How do we know? Exactly. Okay, so this means that as we add antibiotic, bacteria decrease at a rate of 0.83. Now, what does this numerical value actually tell you about the relationship between them? Okay, hopefully you know this by now. When you get an infection, so like you get an ear infection and you go to the doctor and they give you antibiotics, what happens? Well, you take the antibiotics and then that infection goes away, right? Okay, infections are caused by bacteria, fun fact. So hopefully that decreases over time, right? And since that 0.83 is right there, that's directly correlated. That's a very strong correlation. So this means that it is strongly correlated. And we'll get rid of bacteria. And sorry that I'm writing on the bottom of the wall. Okay, the data to the right shows a person's height in feet compared to their height in inches. Use this data to practice calculating the correlation coefficient using Desmos. Okay, you need your laptop. And what you're gonna do is we're gonna type these in to Desmos. So go ahead and take out your laptop, and trust me, you're gonna want to try this because it takes a little bit of practice. Let me set this up really quick. All right, so go to Desmos. And I want you to kind of do this along with me. Go to Desmos graphing calculator. All right, so what you're gonna do is you're gonna go in here and you're going to type, or I'm sorry, you're gonna hit this plus sign and you're gonna type in table, okay? So you're literally gonna copy and paste this table into this, this table into this table. So go ahead and do that now. After you type all this junk in, what you're going to do is you're gonna kind of zoom in so that you can actually like see it, okay? And there are two different ways that you can do finding the correlation coefficient. One of them, you're gonna see this most often, you're gonna actually use this in AP Stat, is Y1, and then you're gonna do this little like tilde. So it's not the straight line, it's like a mustachy looking line, okay? So if you hit shift and then it's like up in the top left-hand corner, okay? And then you're gonna type MX1 plus B, okay? And when you do that, you're gonna get this R value, that 0.992, okay? Now, look at what it does for you. It goes ahead and it writes the equation for you. Okay, so remember how we were doing it by hand yesterday? You don't have to do it by hand. This does it for you, which is great. Yay, technology. Okay, so right here is your correlation value. R equals 0.992. Notice how these dots are pretty much in a straight line, right? Okay, this M and this D down here, we can actually write the equation for this. We can say Y is equal to our M, which is 12.0484, X minus our B value, which is 0.229279. Okay, here's the important thing though. When you put this into your table, at the top of your table, it has to say X1, Y1. If it said X2, Y2, then you would have to change these numbers. Okay, this is what I'm talking about. Up here at the top, let's say it said X2 and then Y1. Then I would come down here and instead of writing X1, I would write X2. Everybody see it? So you got to make sure that those numbers match up. Okay, probably doesn't matter right now since this is probably the first time you opened Desmos today. But if this is the second time you've opened Desmos, those numbers might have changed. Okay, there's something to keep in mind. Okay, another way you can do this, and I just found out about this one, is you can type ORR, and then say X, whatever the number is, comma, Y, whatever the number is. And that also gives me my R value. Okay, so there's two different ways you can do it. The other way, writing the equation will help you when you actually have to write out the equation for this function. Okay, coming back in here, we've got 0.992. Okay, okay, so I'm going to give you a paper. It's gonna be called "Never Know How Far You'll Go" task. I want you and a neighbor looking at this worksheet. So it says, well, can't read it because you can't see it. Yay! What influences travel time besides distance? So like if I was gonna travel from here to Walmart versus here to Panama City, those are two total different distances, so the time's gonna vary, right? What else is gonna impact this travel time? Traffic, yes. Oh my gosh, the construction on I-75. Okay. Okay, what else? Construction. What else? Wrecks. Okay, so I guess I would kind of fall under traffic, but we can put that on here. Wrecks. I don't know about y'all, but I gotta have some snacks. If I don't have snacks, I can't drive very long. Restroom breaks. Gas. That's for sure. If gas is like $5 a gallon versus $3, okay? Whether or not there's children in the car or small children, like if you have siblings or whatever in there, okay? Cool. All right, so which of these factors, including distance, most likely have the most consistent influence of all car trips? What's the most consistent influence? So what's going to make you super late always? Traffic, okay? And the reason why is because it's unexpected. You can't plan for it, right? Okay, but there's always traffic somewhere. Like there's 1.5 million people in Gwinnett. Like there's always going to be traffic. Okay. Use technology to create that scatter plot and then explain the meaning of 20, 23. What does this mean? So if the distance is 20 meters, then it's going to take 23 minutes to get there. How far do y'all live from the school roughly? 10, 7. Okay. I live like 40. And I'm on the other side of the county. Yeah. Yeah. So distance definitely influences time, right? Okay. Interesting. Y'all are all 10 minutes away. Thought y'all were more permissive transfers. Nope. Okay. Here's another point on the scatter plot and the meaning of the data point based on the context of the scenario. So if we take 78, 72, that means 78 meters away, it's gonna take 72 minutes. Okay. Whenever we say in context, you're gonna want to look at your X and Y up at the top of your table. Okay. Use technology to find the correlation coefficient. If you missed earlier, here's the takeaway for today. When you go into Desmos, and you try to type in a table, you're going to hit the little plus sign and then hit table, and then you're going to type in all your numbers. Okay. Then you're going to write the equation, and this is the equation you're always going to write. Okay. This tells you what your R is. Okay. When you look down here, R equals 0.9897. Boom, done. Does that make sense? Okay. Need to write this guy down. Always make sure that your table says X1, Y1. If it doesn't say that, you literally can go in there and type X1, Y1. Okay, that's fine. Okay. On the next question, I think I asked about how long would it take if you did 90 meters, right? So the way to do that is you've got to write your equation first. So looking at these parameters, that's going to help you write your equation. So remember, linear functions are y equals mx plus b. So m is 0.928114, x plus our b value, which is 4.14614. Everybody with me on that? Now, 90, you're going to plug it in for x. So 0.928114 times 90 plus 4.14614. And then we're going to type that into our calculator because I don't know that off the top of my head. 2.814 times 90 plus 4.14614. So that's going to take 87.6764 minutes. So we're going to say 87.6764. And you could have rounded that, but that's okay. Does that make sense? Everybody see how I did that? So you should know how to find the correlation coefficient, and you should know how to find the line of the equation. Yesterday we did it by hand. It takes too long. Use technology. Okay. Questions? Fantastic. So again, you don't have this paper. We're going to kind of talk through these because they don't take very long. So looking at the problem on the board, what do you notice? What do you wonder? Okay, the first thing you always want to do when you look at these things is look at your X value and your Y value. That tells you a story about what's going on in the graph. So what's happening here? Look at your X, look at your Y value. So what does it say on the bottom? Number of people. And then what does it say on the y-axis? Maximum noise level, right? Maximum noise level. So the more people we have, the louder it's going to be. Does that make sense? Feel like everybody got that. Okay. Did you know you can really like bust your eardrum if you go to like a concert? Like, and people don't notice it until like the day after, and they lose their hearing. You gotta be careful with that kind of stuff. I'm not saying don't go to concerts. I'm saying be careful. Okay. So the science of sound. I don't know how to pronounce this. And acousticist. I don't know how to say it. Okay, the person who studies science of sound created a scatter plot to measure the loudest measured noise compared to the amount of fans in an arena over the course of a few months. Line of best fit was created. Using this model, predict the maximum noise level when 75,000 fans are present in the arena. So how do we solve this? What are we going to do? We got an equation, and we're trying to figure out how loud it's going to be if I have 75,000 fans. So what am I going to do for this equation? It's not a trick question. You're going to plug it in. Yes, exactly. Good job. Woohoo. So when you substitute this in, this is going to give you 112,522.70. That's real loud. Okay. How many of y'all been to a UGA game? Yeah, that's what I figured. 96,000 people in that stadium. I don't know if y'all can imagine that many people, but it's a lot and it's very, 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 very loud. Okay. Now here is the tricky part. This question is the same setup, but using this model, predict the number of people present if the maximum noise level was 120 decibels. So what are we going to do? Plug in where? For X or Y? For Y. So we're going to say 120 is equal to 1.5x plus 22.7. Okay. Now you can sit here and you can actually calculate this out, or you can go into Desmos. And we talked about this the other day. Use Desmos. You can take this equation and literally type it out. And you're going to have to zoom out. But look at where it crosses the x-axis. So x is going to equal 64.867. I didn't have to do any math. Desmos does it for me. Please don't get solving questions wrong. Okay. Now what you can do is you can subtract 22.7, and then you can divide by 1.5. So you can sit there and you can go, okay, let me solve this out by hand. And that's going to give you 97.3. We're going to divide by 1.5. You get the exact same thing. Cool? Okay. Again, don't get those questions wrong. There. Okay. Is that the right one? There it is. Okay, what is the slope of the line of best fit? So what is the slope of this equation? Again, not a trick question. 1.5, right? Okay, now what does that mean in context? Okay, whenever we ask for in context, you're going to use the words that are on the x-axis. You're going to use the words on the y-axis. That means as we increase in decibels, as we increase in the number of people, we're increasing in the number of decimals. So for every one person, that increases the noise level 1.5 decibels. That's what that means. That's slope. Y over X, right? Now, what is the y-intercept of this guy? Okay, and what does that mean in context? Okay, but it's with no people. So how does that make sense? When you go outside, is it ever quiet? No, what's going on outside? Nature. So we got birds chirping, we've got cars going, we've got whatever's going on, wind, trees, etc. Right? It's never quiet. So that 22.7 represents, hey, the initial amount of noise. Okay, if you had to estimate what the correlation coefficient was for this one, what would it be? If you had to estimate the correlation coefficient. So how close are those things together? Pretty close. Okay, so it's going to be closer to 1, right? Yeah. So it's going to be 0.7, 0.8. They're pretty close. Okay. So now what I want you to do is look at the agree, disagree statement worksheet that you should have picked up. Okay. We're going to work on that. Okay. I want you to read those questions over and you're going to put agree or disagree and then tell me why. Okay. I'm going to give you about, let's take about 5 minutes. It shouldn't take you very long.